For video 2 of our Snell's Law experiment, I'd like to introduce you to the apparatus that we're going to be using for the rest of the lab. This is our red laser. It produces a red beam of light into our Snell's Law apparatus. And you'll notice that the beam of light is going into this surface, which is a semicircle filled with water. And I actually put a tiny bit of creamer in it so that we could actually see the laser beam as it goes through. All right, I've set up our apparatus so that the laser beam is traveling straight directly through our apparatus, completely perpendicular. So you'll notice that we're set up at 90 degrees right now, and the beam is traveling directly through the center and directly onto the 270 degree mark. So the idea is that that can be used as our perpendicular line. So 90 degrees coming in here is perpendicular, and 270 degrees on this end is considered perpendicular on that side. And what we're going to be doing through this lab is we're going to be taking a bunch of measurements. I'm going to tilt it at a certain angle, and we're going to look at the angle that it's coming in and the angle that it's going out, take some measurements, and do some Snell's Law type things with it. One thing I'd like you to notice about our apparatus too is that the semicircle of plexi that this is made out of will make it so that as I rotate this apparatus, the light will always be coming in perpendicular to the surface, so there will be no bending of light from this air to this water. All of the bending is going to be happening from the water to the air here. Notice that now it's coming in at a different angle and it's going out at a different angle. So in this case, our Snell's Law equation is going to look something like N water theta water is equal to N air theta air. That's where the bending is going to be happening. That's the interface that we're going to be examining. I've actually already gone ahead and made it so that this laser is directly shooting straight through into this apparatus. But even so, I would still want to take data on both sides of the normal. So what that means is that I'm going to move it, let's say 5 degrees on this side, we're going to take a measurement, and then we're going to come back and we're going to do 5 degrees on the other side and take a measurement over here. And the question that I wanted to ask in this video is that why is it important that we take measurements from both sides of the normal? All right, next video we're going to be taking a lot of measurements, so be ready with an Excel spreadsheet, and I'll catch you there.